of things. I'm not sure, but did we exhaust this material, this past paper? I think we did. We did exhaust everything. Okay. So in today's class, we are going to go over some very important things. Very, very important things. At a point, I'm looking at doing graph of motions with you guys, and I'm still contemplating doing that. So either of the ways, or either ways, we're going to go as the emotion moves us. Okay, so in the last class, I explained a lot of things regarding these guys. Equation of motion, linear motion, and I want to start this class from particle motion. So apart from linear motion, we also have other types of motion. We have the vertical motion, and we have motion in at a particular angle, and we have the projectile motion. So those guys are what I will be explaining into this class, and I'll be explaining a bit of things about trigonometry so that we can quickly move and do what we are supposed to do. So I think it makes sense to do that. Then tomorrow we'll talk about graphs of motion, and we can conclude all what has to do with kinematics, so that next week we can do dynamics. Okay. So this formula here, and everything that has to do with this formula, it has to do with a motion from a point A to a point B on a straight line. That is exactly why we call it linear motion or translational motion or rectilinear motion. Now, it is possible that the particle we are interested in is not linear, but is going up and down, up or coming down. Now, when the motion is coming up or going down, it does so under the influence of gravity. So we are not the one influencing the acceleration. For example, it's not possible for you to put your phone up. You take your phone up and leave it there and say, "Because okay, I just want to keep my phone in the air." Is it possible? It's not possible. The phone will fall down. Once you put it in the air and you remove your hand, what will happen? It will fall. And it will either break or what? Or chatter. That is because there's a force, an influence, a pull, a push force that is acting on what? On that phone that you kept in the air. But when you park your car and you leave your car, you don't need anything. Once you keep your car or you keep your phone on the floor, it cannot keep going itself. It's not possible. It cannot keep going to the right or to the left. It's not possible. But when you keep your phone in the air, up, and you remove your hand, it falls down. That is because there is a force pushing it downward. And that is what? The gravitational pull. G. G. So when something is going up, you see this gravitational pull. Its effect is to push everything to the center of the earth. Its effect is to push everything to the center of the earth. So it means that when you launch something up, when you throw something up, that thing is going against gravity. Something up, that thing is going to be negative G. Negative. But when you allow something come down, when you put your phone in the air and you remove your hand, you don't need any force to push that thing down. So when something is coming down, it is coming with a positive G. Do you understand it? Now, our S, which stands for distance, So the S, which is our distance in S equals to UT plus half x squared, this equals to U squared plus 2x. That S here is going to change to height, which is going to be h. Do you understand? So those are the things that we need to consider. So when we are going up, we are going against gravity. All these formulas are what we use. We are going up. When I'm talking about upward, we use everything we have minus minus. When we are talking about downward, we use everywhere we have what plus 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 downward. Is it clear, guys? S will change to H, and the what's it called, and the G, the acceleration is going to change to what G. Now we are not the one influencing the acceleration. Now the acceleration is due to what the gravitational pull. Do you understand? That's number one. Now, when we throw an object up, when you throw an object up, when you throw an object up, let's say with a velocity of maybe 30 meters per second, it will go. As it is going, gravity is working to stop that object. Once that object gets to a particular height, it is going to stop temporarily. It is not as if it's going to stop and say, hey, Khadija, look at me, I'm talking so that I can see you. Yeah, Khadija, see me. Can you see me? Yes, I can see you. It will not come down. No. It will not stop to talk to you. It will stop temporarily. That point whereby the object is stopping is called greatest height or maximum height. And there's only one reason why the object is stopping. It's stopping because its velocity is now zero. It has exhausted its velocity. So at maximum height, the velocity, the final velocity v is always what? Zero. You have to know this one. Don't forget that you are throwing it up. It means that at this maximum height, we can say that the formula v is equals to u minus gt. It's going to change to what? 0 is equals to u minus gt. And if you want to know the time that you take you to get to maximum height, you can just bring gt and say gt is equals to u divided by g divided by g. So t to get to maximum height, the formula will just be what? U over g. So with this velocity now, 30 meters per second, if I ask you to tell me the time it will take this object to get to maximum height, we can do it. See, maximum height will just be what? 30 over g. Now, this g is a constant. It can be 10 meters per second square. It can be 9.8 meters per second square. It can be 9.78 meters per second square. Now, if you are not given the value of g, you can use 10 as your base. So let's use 10 here. So it means that to take this object that is moving with a velocity of 30 meters per second, it takes it 3 seconds to get to maximum height. Is that clear? Don't forget this formula. Anytime you even yourself, you perceive that that object is thrown upward, and you have to calculate the time to get to maximum height, just use the formula u over g. Don't stress yourself. U over g. Now, the maximum height itself, what will be the maximum height? So let's say also at maximum height, what happens at maximum height? V is always equals to 0. So from the formula v squared is equals to u squared minus 2gh. What will happen? This will be 0. So 0 squared is equals to u squared minus 2gh. So bring 2gh here. 2gh is equals to u squared divided by 2g divided by 2g. H is equals to u squared over 2g. So the maximum height itself will be what? U squared over 2g. That will be 30 squared over 2 times 10. That will be 900 over 20. 0, 0, that will be 45 meters. So you will take it 3 seconds to get to the height 45, and that will be the maximum. At that point, it is going to come down. Boom. Is that correct? So somebody asks that, why is this value? Why is it changing? 9.8 meters per hour. It's not clear, Rashida. Someone why is this value? Why is it changing? It is because it varies from places to places. Here in Lagos, in Nigeria, the gravitational pull is 9.8. In London, it is 9.87. So the approximate it will be 10. So it's just changing just a bit. On the moon, it is 3 point something, 3.12 meters per second squared. So that's where they experience weightlessness. It is as if there is no weight here. So when you go up like this, you keep going. When you throw something up, it keeps going until it's hit another thing bounces to the other side. Do you understand? They express something called weightlessness. So it's gravitational pull. It varies by what? By location. Do you understand? So, but the one we experience on the surface of the earth is the one that when you throw something up, that thing will actually definitely want to come down. Do you understand? So Aisha and I think Kiba, they don't seem to understand this part of the formula. So I'll just explain this again. When you throw something, when you go, so this formula is of two types. Vertical motion. This motion is when something is going up or down. So the formula for upward and the formula for downward, they differ. When you are going up, it's different when you are coming down. When you are going up, you are going against gravity. So your G is going to be negative. When you are coming down, you are coming with gravity. So your G is going to be positive. So the formula V is equals to U minus GT. H is equals to UT minus half GT squared. Then V squared is equals to squared minus 2GH. For downward, we have V is equals to U plus GT. H is equals to UT plus half GT squared. Then V squared is equals to U squared plus 2GH. Now, when we now throw something up, it will get to a point. Let's say we throw an object with a velocity of 20 meters per second. It will get to a point whereby that object is going to stop temporarily. Once it stops, it's not as if, because I know some of you are already throwing something up and seeing if that thing is going to stop. See, when it stops, it will now tell you that, Aisha, look at me. Aisha, can you see me that I'm stopping now? I'm stopping for you. No. But it will get to a point whereby it will not, velocity, it has exhausted its velocity. It cannot keep going. What do you read? So at that point, what you learn, we say we have maximum height. 8 max. And then at that point where you have your maximum height, your velocity, final velocity V, is equals to 0. Think of the velocity as the fuel driving it. Low. So what will happen? Keep going. The car will stop. Do you understand? That's why that maximum height, once the maximum height is attained, the object stops temporarily and it falls down. It comes down. What do you think will happen if the aeroplane of a fuel gets exhausted? What do you think will happen? It will pack up. It will pack. Okay. Listen, that's what they say. I get packs. Okay. Is that what will happen? What will happen when the velocity, when the fuel of an aeroplane gets exhausted?
It fails and
I want
crash.
it's what?
It fails and crash.
It's going to fall and crash. How's the line in such? That's the
Yeah?
fact. Actually, it's going to fall and crash. It's going to fall and crash, actually. So the bottom line is that at that maximum height, the final velocity is 0. That's why it cannot go again. What you low velocity, low speed, it has exhausted the speed. What you read? ó kàn máa já wálẹ̀. But to já wálẹ̀ kò ní the speed láti já wálẹ̀. Why? Because gravity ló máa tì wálẹ̀. That's why something cannot hang up. Nǹkan ò ní hang sókè. When I get this point, I like to tell my students the story of Lala. So if you have attended this my class before, you will know the story of Lala. Most of you are Yoruba. I don't know if you guys are Yoruba, but I think most of you are Yoruba. So there's one proverb that states that Lala Toroke ilẹ̀ ló ń bọ̀. I mean that Dostunu, you are not Yoruba. Even your name Dostunu is Yoruba. Lala Toroke ilẹ̀ ló ń bọ̀. It means that whatever goes up will surely come down. That's the meaning. So I'm very inquisitive. I like to ask my grammar questions. So I asked her the question of Lala, the story of Lala. What's the meaning of Lala? Like, I don't understand. So she explained the story of Lala to me. That Lala is a magician. He does magic. So he performs magic, sometimes going to disappear and reappear. So he now called everybody in the village. That people will come that wants to perform a very big magic that they've not seen the type before. That's going to go up. Going to go up for a long time. So that Lala man performed the magic, and when they saw him ascend, going up, who's that shouting? Lala Toroke, Lala Toroke, could do. I mean, that went up did not come back because he did not come back for days. After a while, after like 3-4 days, people just heard me. When they came out, they saw the hand of human being. This is hand now. This is hand. Hand. This hand is looking like Lala's hand. Though. Or you don't see what we are seeing. Say, yeah, yes, so this is Lala's hand. It looks like, okay, they went back inside. After a while, they heard, they went outside again. This is looking like Lego. This leg is Lala's Lego. When you say Jack Robinson, all of Lala's body came down. So they transformed that over from Lala Toroke Ode to what? Lala Toroke Ilẹ̀ ló ń bọ̀. That's to tell you about gravity. There's no how you go up, you surely come down. If you think that no problem, we are going to Saudi Arabia, going to enter inside the cloud, you are not going to come down. Then you come back in peace or in pieces. One of the two is going to happen. So Lala failed to come back in peace. He came in pieces. So Lala Toroke Ilẹ̀ ló ń bọ̀. So no matter how, anything you do, once you throw something up, it will probably come down. You cannot hang the air when it's not possible. You can't hang it in the air. There's no technology that can hang something in the air. And skyscraper, it has suspension. It's suspended. So maybe people will start buying, once you exhaust the land market in the whole world, people will start buying space in the air. We are hoping for that. But we all know what's going to be the effect. Either they come down in peace or in pieces. One of the two is going to happen. So once an object gets to its maximum height, the final velocity v is equals to 0. Is that correct? So in that case, what will happen is this. This place that we have v and this place that we have v, we want to subject them to maximum height. So at maximum height, the formula v is equals to u minus gt, and the formula v squared is equals to u squared minus 2gh. At maximum height, v will be equals to 0. Here also, v will be equals to 0. So here that v is equals to 0, we say 0 is equals to u minus gt. Here also that v is equals to 0, we say 0 squared is equals to u squared minus 2gh. So let's make this stand alone so that we can even know the time to get to that maximum height. What is going to be the time? This formula here already is at maximum height already. But what time are we going to need to get to maximum? That's what we want to find from this formula. So bring dt here. So gt is equals to u divided by g. So t to get to maximum height is going to be what? U over g. This is how to get to maximum height. Don't forget that you cannot get to maximum height unless you are going up. That's why you are using upward motion formula. You can you are not using downward formula because you can. When you are coming down, you cannot get to maximum height. You are coming down, you are descending. Do you understand? So physicists and mathematicians, they have sense. You can't use this formula to prove this thing. It's not possible. Do you understand? Because to go up, you have to use the upward formula. That's what I said. I'm using the formula that has minus. Here also, What is going to be the value of that maximum height? That's what I want to find from here. Bring 2gh to this side. 2gh is equal to u squared divided by 2g divided by 2g. We want h to stand alone. So anything that is determining h, we want to take it away, which is 2g. So h will be equals to u squared over 2g. So this formula here is the formula to get to maximum height. So a question will now come and say, an object is thrown upward with a velocity of 20 meters per second. What is the time to get to the maximum height? This is the formula you are going to use. Time to get to maximum height will just be 20 over 10, which will be what? 8 seconds. What is the maximum height attained? The maximum height is going to be 8 is equal to 20 squared over 2 times 10. 20 squared is 400. U squared, that's 20 squared over 2 times 10, that's 20. 0, 0, 20, 40, 20. So the maximum height will be what? 20 meters. That height attained by that object that is moving with an initial velocity of 20 meters per second. Is that clear? Is that clear, guys? Excellent. Okay, guys. Now, if all of this is clear, then we can move to something a bit more interesting. I love to talk about this as well. How do we do this? How do we do this? When we see a question, we'll talk about it. Okay, that's one. Two. It is possible that instead of the object going up and down, it is on an inclined plane. Like this. So the object is here. Now, we have studied when the object is going up, when it's going from right to left or left to right. And we've studied when it's going up to down. Abby? We have solved the example on this, but we have not looked at examples on this. We are going to look at that. It is also possible that the object is launched at a particular angle, theta. In that case, we have to resolve some vectors, some things. Don't worry. It's not difficult. You'll know it, you'll understand it now. One thing is certain. There's something pulling the object down like this. And that is gravity. Abby? What we are interested in is the force that will take it up, like this, or the speed that will take it like this. How we are interested in. But there is also a weight force here. and another balance force here. In physics, we have two types of force. So what we are interested in is the speed that it will take to go up, negative g, and the speed it will take it to come down, plus g. But we also have some forces that will balance it, the weight force. So here, by geometry, whatever this place is, this place will also be theta. So I can produce a line like this. Now, parallel to this one. So this is going to be my x, and this is going to be my y. This is my geometry. We take sine theta. Sine theta is opposite over hypotenuse. So our opposite is what? X. And our hypotenuse is what? The g, gravity. So we say sine theta is equal to x over g. So once you cross multiply, x will be g sine theta. That's what we are looking for. This line here is parallel to this line here. So it means that for this guy to go up, it will go with negative g sine theta. For this guy to come down, it will come down with plus g sine theta. Is this correct? Actually, you close your eyes when I started this and you open your eyes again, you see that you are lost. when we started this, just close your eyes and open. Hey, what is this? The law is actually very simple. Now, what is important is not this diagram that I've drawn. What is important is that when an object is projected at a particular angle theta, the gravity that will take it up is not g again. It will be d sine theta. Do you understand? So if it is going up, it will be minus g sine theta. If it is coming down to a plus delta, what do I mean? Now let's come back and look at it like this. If you are going up now, under motion, this topic now is motion on an inclined plane. That's the topic we are looking at now. We have left vertical motion now. Now, when you are going up, it's different when you are coming down. So I'll write the formulas separately. What is important is this guy that I have solved here. The component, g sine theta, is the most important thing. So the upward, when you have your formula, v is equals to u minus, so it's supposed to be dt. Now you have g sine theta t. Just change your g to g sine theta, don't worry. The second one will be what? H is equals to ut minus half g sine theta t squared. H is equals to ut sine ut plus half gt squared. So that g has changed to g sine theta. The third one will be what? V squared is equals to u squared minus 2g sine theta h u squared minus 2gh. Abi? That's for upward. For downward, V is equals to u plus g sine theta t. H is equals to ut plus half g sine theta t squared. V squared is equals to ut plus 2g sine theta h. You might be asking that, when do we need all these things? Like I told you, this is not SSC. You will see questions and you'll be surprised. Where are they coming from? What are they asking you? From this topic, I'm going to jump quickly to the topic called projectiles. Now, at this point now, this is what is important that you guys need to know. You guys need to sit down to go and see this. The formulas are the same, just that the cases are different. At some point, it will be V is equal to U plus AC. V is equal to V squared is equal to U squared plus 2S. Now, you can see the way we are changing that same formula to suit our interest. Now, projectile motion. When we say projectile motion, what do we mean? A projectile is an object that we throw and is allowed to move freely under the influence of gravity. Projectile motion is a motion that is launched in the air. A very good example is when Ronaldo plays a free kick. He's standing here, and we have the wall here, and we have the goal post here, and the ball is here. And he launched the ball above the player, and it enters into the water. This movement of this ball now is what? Is a projectile motion. That's number one. This part that the ball traveled in is called trajectory. The part of travel of the projectile is called what? Trajectory. Part of travel of a projectile. Now, when we throw an object, it's a projectile motion. That object is going to have a shape like this shape you can see now. The shape of a projectile motion is called a parabola. All those things are important though. Projectile is different. Projectile is a missile or an object that is allowed to move freely under the influence of gravity. An object thrown into the air and allowed to move freely under the influence of what? Of gravity. That's called projectile. Examples: Ronaldo playing a free kick. That ball, the motion of that ball is a projectile motion. An hunter that shots an arrow into the air, or a catapult shot into the air, or a javelin shot into the air, or a shot put shot into the air, or a discus shot into the air, or a golf played into the air. I've seen a golf before. Golf is a big man sport. Big men play golf. Only big men. You can't see a small boy like me and Benny Becker playing golf. Sorry, Benny Becker. Benny Becker can be a big man. Sorry. Only you. Bear into positive and negative name. Benny Becker. Only you. Are you in this class, Benny Becker? So Benny Becker is a big man. So it's possible that he has played golf. Me, I've not. In fact, I've not held a golf stick before in my life. There's still so many things I want to do in this life. I've not had a golf stick before. I also want to have a ranch where I can rear my horses. I want to have a horse ranch. That one too. Saving money. People are saving money for BMF, for G, for storage. Turn your browser to see. So you're going to do it. So projectile, those are examples of projectile motion. Do you understand? Now, that projectile launched into the air. When Becker is confessing. That projectile launched into the part of travel of that projectile is called trajectory. And when that projectile is launched into the air, it forms a particular shape. That shape is called a parabola. Don't mess yourself, just cram it. In mathematics, when we draw the graph of x squared or ax squared plus bx plus c, we say the shape of this thing is what? Is a parabola, U or N. This is what they mean by parabola. When you launch it from here to back, that's it. Hello, that's what we call what? A parabola. Do you understand? Now let me give you that and draw it. Now, in graph, this place is the y-axis, and this place is the x-axis. This is the starting point, U. So when you go here, I'm calling it U because we are starting with an initial velocity U. So when we go here, we say we are moving with ux. That's initial velocity to the x-axis. When we go up here, we say we have uy. That's initial velocity to the y-axis. Do you understand? Now, we now launch a ball at a particular degree, theta. This ball, we are now drawing what we think is going to be the motion diagram of what? Of this projectile. Now, the motion of a projectile is under the influence of two things. Number one, number two. It has the horizontal component, which is ux, horizontal, from x. X is horizontal. And it has vertical component, uy. That's the vertical. Now, at every point, a projectile motion is under the influence of those two components. It is going up at the same time to the right. It is going up and at the same time it is going to the right. It is only at the maximum height that it is not going up. It is under the influence of only one component at that point. It's only going to the right. At what? At H max. From there, it starts coming down and going to the right. Comes down, go to the right. And here it stops. Do we get it? Do you get it? Two things, very important. It is going up and it is going to the right. So it's under two influence. The horizontal influence and the vertical influence. So when we try to solve anything we want to solve for under projectile motion, we always use the horizontal resolution and the vertical resolution. We use both together to get all what is important under projectile motion. Now, what are the things that are important under projectile motion? Number one, time of flight. Time of flight is the time that it takes a projectile to travel from where it is projected to where it is going. If you go to the newspaper, you find a very better definition. So the time of flight is the time required for a projectile to travel from the place of projection to the point where the projectile hits the projection plane again. Time of flight. The formula is 2u sine theta over g. Time of flight. Now, there's another time. Let me tell you fast. That time is time to get to maximum height. That one is not the time the projectile motion is going to take to travel from this point to the maximum height. Ota. Because the maximum height is always going to look like, it's going to look like a symmetry. Is a line that is going to divide the projectile shape into two types, into two halves. So the time it will take you to move from where it was projected to the maximum height is the same time to take you from the maximum height to the projection plane again. So that time to get to maximum height is just half of time of flight. So we say that time of flight is equals to 2 time of what? Maximum height. So we can say that time to get to maximum height is u sine theta over g without the 2. Do you understand? Without the 2. Is that clear? That is time of flight. Is that clear? I'm not getting a response from you guys. It's looking like you guys are tired of not enjoying the class. Okay. Number 2. I have maximum height, which is sometimes called greatest height. The formula is u squared sine squared theta over 2g. This maximum height is the highest vertical point attained by the projectile. I don't know if it's my phone, but it is cracking so bad. Is it cracking, guys? Can you guys hear me? Can you hear me? Yeah. Who can hear me clearly? If you can hear me clearly, please tell me, let me know.
I can hear you clearly.
Likewise me.
I'm speaking like you're the only one that can hear me clearly.
Likewise me.
And me too.
That means that it is
I can
you
hear
guys
you
network.
clearly.
Don't think that I use the network. Because you guys, all of you are from Edo.
I can hear you
That's
clearly.
fine. This is I can hear you.
So I
You guys
can hear
you're
you.
not from Edo. That's fine. But like here in Accra now, you guys cannot hear me. None of them are from Edo. You can see Edo people or trust it. I have that I am. You can see Edo people. Edo people. Those are my people. Okay. This maximum is not maximum. I'll come back to the formula and tell you what we do with it. Number 3, I have range. The range is u sine 2 theta over g. I hope I'm correct. U square sine 2 theta over g. This range is the horizontal distance measured from the start point of the projectile to the end point of the projectile. That's the range, the horizontal distance. So the range now is just from here to here. That's the range of this motion. This one here. The vertical distance as measured from what? From the start of the motion to the end point of the motion. Just horizontal distance. Horizontal. That's some distance to work over. That's range. You're very familiar with sniper movies. You'll be seeing that sniper is always asking the boy that follows the ranger. That's the name of the boy that follows the sniper up and down. So snipers, they always have a machine that they are training. You have again, apprentice. So that apprentice is always called the ranger. Is the one checking the range. To check the range, to check the wind. It will check the range is the distance from where the sniper wants to gun down with enemy. That's the range. That's the function of that guy. You see the guy with the telescope, checking the rain, checking the air, the wind, the humidity, the blah blah, and everything. So they will do a little bit of mathematics, and the sniper can take down its enemy based on its own the the scope of its own gun. So the gun will have a scope. The missile will have its weight, and it will have the length that it can travel also. So they calculate all those things and it can say, okay, I can take down the enemy or not. You guys are surprised how I know all these things. I wanted to become a sniper too before. Before I started sniping people's brain. I wanted to become a sniper, but now I'm engineering people's brain. And can say I'm a teacher. I'm a teacher sniper. I'm a sniper teacher. So I have obsession to sniping. In fact, if I have my way I can still go and join Nigerian Army and be doing sniping and all of that. So anyway, you see me, just run away from me. Okay, so that's range. Now, there's something we talk about in range. We talk about maximum. What is that thing called again? Maximum range. Is it maximum range? This maximum range is attained when our theta is 45 degrees. So the question will come that at maximum range, what is the value of theta? And at maximum value of 45 degrees, I'll tell you guys why. Now, all these formulas I have here are things that we have to know. We have to master them. You have to master them. Now, before we now go, I want to quickly give you guys some things that are very, very useful. Now, theta is angled. And there's no way you can do sine theta in mathematics. No how, especially in physics, without using a calculator. So you have to learn something before we now dive into solving questions. All these things I'm saying, I'm not starting solving questions. So some of the questions that you have, I'll answer them when we start solving questions. You understand? I'll answer some of the questions that you have when we start solving questions. But for now, I still just want to talk about what is important for me. What's going to help me solve questions without you guys asking me a lot of questions. Is that clear? Now, there are some special angles that you guys need to know. For example, 0 degree, 30 degree, 60 degree, 45 degree, 60 degree, 90 degree. This one is okay for projectile. Now, sine 30 is 0.5 or 1/2. Sine 45 is 0.7071 or √2/2. Don't think that I'm looking at it from one place. So, no, I don't have, in fact, I don't have any feelings at the moment as I'm stop doing this class. I don't have any feelings with me. So you have to know it. That's my bonus contention. You have to know it. You have to know it in line with this. Sine 60 is 0.8660 or √3/2. Now, if you look at it from 0.5 to 0.7 to 0.8, you see that you can see increase. Sine 0 is 0 and sine 90 is 1. So it's going from 0 to 1. You need to after 0.5, after 0.7071, after 0.860, after that 1. Exactly.
So please, network is not okay.
It's not my network. Your network. Are you also from there? Oh, don't stay.
No, sir, it's cracking.
It's cracking. Is it still cracking now?
No, sir.
Okay. Now, for course, it's cracking. Okay, let's see. Okay, is the network okay now, guys? Thank you. Now, for cos 0 is going to be 1. Cos 90 is 0. I will tell you why. Sin 30 is 0. Sorry, cos 30 is 0.8660, which is 3/2. Cos 45 is the same thing as sin 45. So that's 0.7071 or 2/2. Cos sin 60 will be the same thing as cos 60 will be the same thing as sin 30, which is 0.5 or 1/2. Why is sin and cos looking like they are opposite to each other? The reason is because the word sine is actually sine, like this. And the word cos is actually cosine, like this, cosine. You can see that inside sine, there's cosine there. Inside cosine, there's sine there. This co stands for complementary of sine. And when we say two angles are complementary, it means that at the same time, they add up to give us 90 degrees. That's why cos 0 and sine 90 are the same thing. Cos 0, 1, sine 90, 1. Can you see? Cos 30 and sine 60 is the same thing. Cos 30, sine 60, the same thing. Because 30 and 60, 90. 90 and 0, 90. That's why cos 45 and sine 45 would give us the same thing as well. 45 plus 45, 90. Is that clear? This one is mass. Yes, I know. But we need it here. Now, tan. The tan of anything is just sine over cos. Sine over cos. So tan 0 now is just do 0/1. This one, you just do 0.5. So you just do sine over cos, and that's how you go from this table. And you can fill it in. Is that clear, guys? Excellent. Now, there are some things that we also need to talk about here that I've not talked about. And there are some things that we need to talk about under projectile also that I've not talked about. But I think I've cut across basically all what is important in the theory aspects. And every other thing will just be calculation and some other things that I have not talked about in calculation. Now, quickly, I'll move to the last part of today's class. I know I have not solved question. Don't worry. If you don't understand all what we are doing, don't worry. Just relax. There is a saying in Arabic that فَبِالْمِثَالِ يَتَّضِحُ الْمَقَالِ. With examples, what we are saying become clearer. So once we see examples now, all what we are doing is going to become more explanatory and clearer. Do you understand? Now, in this case now, let's move to graphs of motion or motion graph. I want to do everything at the same time and we'll finish it. Tomorrow's class, if it will hold, is going to be for solving questions. We just solve questions tomorrow. Now, we have basically what is important to us is two things in physics. We have two types of graph. Distance time and velocity time. Distance time graph is a graph of distance on this axis in meters, then time on this axis in seconds. Velocity time graph is a graph of velocity on this axis in meters per second, then time on this axis in seconds. Can you see? Distance time, velocity time. Then the next question is going to be that when we say this a graph is a distance time, What are we interested in? We are interested in speed or velocity. When we say a graph is velocity time graph, what are we interested in? We are interested in acceleration. Now, the slope of a distance time, mind you, this D can be distance or displacement too. So if it is distance, it is speed. If it is displacement, it is what? It is velocity. So the slope of a distance time graph is what? Is speed. And the slope of a displacement time graph is going to be what? Velocity. Half distance time or displacement time. What it is describing here is what? Is speed or what? Or velocity. Because don't describe for 1 year. It's telling us about the speed and the velocity of what? Of the object or the particle. Is that clear? While the slope of a velocity time graph is discussing about what? About acceleration. Velocity time graph, on the other hand, is talking about acceleration. Everything here under velocity time graph is what? Is acceleration. Everything that we are going to describe it is acceleration. Is that clear? The only thing that Jam will ask you relating to speed, displacement time and this distance time is just going to be to solve some things, which we are going to look at. I have a material already on display questions on that we are going to solve in the next class. But for the velocity time graph, Ben, it will be your network. For velocity time graph, okay, this is my network. That's true. Something happened and the network went off. Truly went off. Let me switch again. The network really went off. You want to see my screen? Right on. Can you hear me now? Loud and clear. Good. So the slope of a velocity time graph is acceleration. The slope of this time graph is what? Is velocity. Now, one thing that is very important is that DAM is going to test you a lot about velocity time graph. So this is velocity time graph here. Now look at this. The velocity time graph. You see at position 0A, at this line here, what we have there is called uniform acceleration. Remember I told you that what velocity time graph wants to describe to us is what? Is acceleration. So when you move from 0 to A, what you have is uniform acceleration. When we say something is uniform, what does it mean? what does it mean? Uniform. The word uniform. What does it mean? If somebody comes to your school and the person does not put on uniform, it will be so obvious for you to note the person. Uniform is something general to everybody. Everybody general. Uniform on it. So when something is uniform, it means that the velocity is increasing as the time is also increasing. Velocity increases as time increases. That's what we call uniform velocity. Sorry, uniform acceleration. The velocity is increasing as time is increasing. That's what we have here as it's going up like this. Can you see? It slopes upward. That's what we call it. It slopes upward. So we have what? Uniform acceleration. If you check AB on the other hand, AB, you see that the velocity is not increasing. The velocity is constant. So at that point, we have zero acceleration or no acceleration. Why? Because the velocity is constant. As the time what? As time increases. The time is increasing, yes. But you see that the time moves from maybe 5 to 10. Can you see? The time increased, yes, but the velocity is the same. Let's say this place is 15 meters per second. The velocity here is 15, here 15, here 15, here 15. At the start of the motion, 15. At the end of the motion, 15. The velocity is constant. Anywhere you have a constant velocity, it means that there's no acceleration. Motor will increase, speed will increase. On maintain bushing learning. In case like it's just maintaining that same speed, no acceleration. At that point, you have what? Same velocity. The velocity is constant all through, but the time increased. Do you understand? Because we can't hold time, so the time increased. If you look at BC, what we have on BC is uniform also. But it is not acceleration, it is what? Deceleration. Uniform deceleration. In uniform deceleration, we say it slopes downward. Slopes downward. What do you observe? Owale. Velocity increase tele. O high tele. O call it jawale. That's what uniform deceleration. So we say the velocity decreases as the time increases. Is this clear? The velocity decreases as the time increases. So these three cases, I want you guys to note these three cases very, very well. Very, very well. For velocity time graph, now you can see I'm expanding on velocity time graph. I'm expatiating on velocity time graph. I've left displacement, displacement and distance time graph. Now let's come here. Let me see if you guys really understood what I've been explaining so far. I want you guys to describe this motion for me. Now, so let's look at OA, AB, BC, CD, DE, and EF. These are all motion that we can describe. The first thing you have to look at is what kind of graph is this? So you have to check the y and the x-axis. So the y is velocity, meter per seconds. The x is time, seconds. Now, from O to A, if you check this graph here that I'm describing at the moment, it is different from this graph here. This graph here started from rest. Can you see? Started from 0. But this one here started from vertical velocity. Can you see? It's not starting from rest. This one started from what? A particular speed. Can you see the difference? That's number one. Now, at OA, what is happening at OA? We have what? 0 acceleration. At AB, we have what? Uniform acceleration. Why? Because it is going up, slopes upward. At BC, we have 0 acceleration again. Why? Because it is parallel. It is a straight line. At CD, we have uniform deceleration. It comes down. And at DE again, we have 0 acceleration. And finally, at EF, we have what? Uniform deceleration. Is this clear? So if this is clear, then all what we need to study under motion has been completed. Under motion, kinematics. Because we have two types. We have dynamics and we have kinematics. Kinematics is the description of how object moves without considering the forces that is causing their motion. You can see here, we are not talking about Newton's first law and second law and third law. We didn't even talk about force because we're not interested in force here. We are just describing our motion. Description of how object moves without regards to forces causing the motion. But under dynamics, we are interested in why objects move as they do. Why objects moves. So that's we're talking about Newton's first law, and second law, and third law, and momentum, and inertia, and conservation of momentum, and energy, work, all those things. Do you understand? So all this, I'm going to leave you guys with all this. Digest it, write notes, make jottings, memorize formula, read more on it. Read more. I hope you guys are reading, Sha. I'm not just sitting down with what we are giving you. I hope you are reading. So in our class tomorrow, I'm going to solve questions for you. If the class tomorrow is going to hold, I can't say for now. But I'm going to solve enough questions for you guys that is going to be explanatory. We are going to work on so many things. Even if you have questions, some of these things I'm going to say them again. Do you understand? I'm going to say some of these things again and again. But if you go over all of these things and you read more on them in your new school physics, I have friends that don't like new school physics, and I don't have any reason not to like the textbook. But I have some very good friends that are very good in physics and they don't like new school physics. They are very good. But me, I don't have reason not to like the textbook. So you can go to your new school physics and study more on all the topics that I've said. Some of the things that I've said, you see there, and most of what I've said, you will not see it there actually. So please ensure that as much as we are explaining and teaching you guys, you're also going back to study and learn. Do you understand? So I'll see you guys tomorrow if the class tomorrow would. Thank you so much for your patience. And I rest my case here. Thank you.
جزاكم الله خير.
Amin wa antum. Nafisa Akurege.
Jazakumullahu khairan, sir.
Amin. Aisha. Amin. Amida. Amin. Benny Beko. Amin. If you can leave the call, you can leave. I have to remove everyone because I can't stop the recordings unless I remove everyone. That's why I'm removing you one by one. So if you can leave, you can help me. Thank you. I know that Rema will be the last person to leave. Except, yeah,